Okay, folks, here we are today. I'm going to make a video on the lesson for today and tomorrow. And we're going to learn about taking derivatives. Of two types of functions. We're going to work with exponentials. G-I-A-L-S. And we're going to work with ln functions, natural log functions. We're going to talk about the rules for two in a minute, but exponential function is going to be one where the variable is in the exponent. Those are exponential functions because there's a variable in the exponent, and natural log functions are going to look like this. Third. Going to be kind of all over the place. So before we talk about the derivative pieces of those, let's talk about the relationship first of all between exponentials and log functions. Any exponential function, 2 to the x equals 17, can be written, this is just background for the stuff, can be written as a log function. This is log base 2, 17 equals x. The two most common bases we use are base 10, that would be a log function. There's no base there, that means it's base 10, or we'll use a natural log, base 14, where e is the number that's actually down here. We don't write it, but we know that number is there. So we are going to start by taking the derivatives of exponential functions. Okay? So what we're going to do is I'm going to flip to my calculator. I'm going to enter in a function. I'm going to enter in 2 to the x.
Mr. Brigham, ready?
I hit enter. And we can see that's our exponential function right there, 2 to the x. I'm now going to graph its derivative. I'm going to go to the function right there. I'm going to type in nderiv, which means take the derivative. V, start parentheses. I'm going to click the var button. F1 of x, comma, x. And what do you notice about the derivative of 2 to the x? It's very similar to the original function. As a matter of fact, I can tell by looking at the derivative of this function, its derivative is an exponential function as well, because the graph kind of matches it almost exactly. It's almost exactly the same as its original function. Let's try another one just to check. I'm going to tab back up, and I'm going to go to F1. I'm going to change this to 3 to the x. Hit enter. And hey, that's closer. That looks pretty good. I'm going to zoom in. Menu. Zoom in. And it's closer, but it's not exactly it. As a matter of fact, we can see that the derivative of this exponential function is also an exponential function. And the derivative of 2 is also an exponential function. But the question is, which one is going to match exactly? Which one's going to go right over itself and have its own derivative? Well, it's going to be one that's somewhere between 3 and 2. It's going to be somewhere that's really close to 3, I think. Let's go tab. I'm going to change it to 2.71828. This is a random guess. 1828459.045 to the x. Hit enter. And take a look at that, folks. The derivative of 2.71828.459.045 to the x is exactly the same as its derivative. Now, how did Mr. Brigham just figure that out? Mr. Brigham knows that the only function who is its own derivative is that function right there. And 2.71828.1828.4590. 45 is a special number. So the first new rule I'm going to have is that the derivative of e to the x is e to the x. It's the only one where that's the case. That makes e such a powerful number. Its derivative, it starts as an exponential. Its derivative is an exponential as well, and it's the exact same value. Other derivatives of other exponential functions come close, 2 to the x. As a matter of fact, if I start with 2 to the x, I know the derivative looks like itself, 2 to the x, but it's just dilated, shifted up or down just a little bit. The amount it's shifted up or down is always equal to the ln of the base. So the derivative of 2 to the x is 2 to the x ln of 2. Whatever number this is right here, for an exponential function, its derivative is always itself times the ln of the base. And that's how derivatives for exponential functions work. Quick example of a problem would be like so. If I started out with e to the 7x, I'm using the chain rule now. The derivative of any exponential function is itself times the derivative of the inside, which is right here, which is 7. If I have 2 to the sine x, it's going to be itself, 2 to the sine x, times the constant that's a little bit off by, ln of 2, times the derivative of this function right here, sine of x, which is cosine of x. Well, I heard Lucas just ask a question. He said, wait, why are there different rules for the derivative of e to the x and the derivative of some number to the x? If this one is 12 to the x times the ln of 12, technically shouldn't the derivative of e to the x be e to the x times the ln of e? Guess what, folks? Lucas is right. But e and ln are inverses of each other, so these cancel each other out. The ln of e is equal to 1, so we just get back e to the x. So technically every exponential function is itself, derivative is itself times the ln of the base. Always going to work out that way. Okay, so I'm going to explain something now involving natural log, finding the derivative of ln functions. So the work I put on this page, I'm putting a star here. You don't have to repeat. It's just where the rule comes from. If I wrote down y equals ln of x, I don't know what the derivative of that is. But I'm going to convert this to an exponential function. The base is e, the exponent is y equals x. So now I'm going to take the derivative of this function, and this is something new we're going to learn about later on. See how the y is up here? It's not by itself. If I take the derivative of y, anytime I do that, of a different variable other than x, I have to include a y prime on there. It's called implicit differentiation. We're going to do it later. Don't worry about it now. If I take the derivative of this, the derivative of x is 1, and the derivative of an exponential function, e to the y, is e to the y, times the derivative of this, which is y prime. So if I want to know what y prime is equal to, which is the derivative of the original function, y prime equals 1 over e to the y. And that's my answer. But look what we already knew. E to the y equals x, so y prime is equal to 1 over x. We now have our new rule. If we have a function, ln of x, I see the word line in here, line, and the derivative of ln of x. So, 1 dx equals 1 over x. And there's the line again. So ln functions are actually pretty easy to take the derivative of. I'll write 3 down. ln of x squared, ln of 3x, and then ln of sine of x. The outside function on all of these is ln, so the derivative of a line, ln, is 1 over what we started with, times the derivative of the inside, which is this right here. So it's times 2x, this is times 3, and this is times cosine of x. I could leave them all like that. It's totally fine. With multiple choices, they'll often cancel, and this will happen all the time. This will cancel with this. This will cancel with this. And we're left with 2 over x, something over x. We're left with 1 over x. And I'm going to be tricky on this one. I would have left it like that, but sometimes on multiple choice, the answer you'll see would be cotangent of x. How do they get that from there? Well, they combine these two things together and realize it's equal to that. So for today, the only parts you have to worry about are these right here. And we're using just these new rules and the chain rule. Let me try one from your homework assignment to help you get ahead a little bit. I'm going to go to a new page. And let's get y equals, this is number 9, y equals e to the 5x to the 4th. I already know it's an exponential function, so I know its original is going to be there, 5x to the 4th. The derivative of e to the something is e to the something. So then I'm going to multiply that by the derivative of the inside, which is the top. And that would be 20x to the 3rd. And I can leave that answer just like that. That's just fine. Let's go on to number 19, which is y equals ln of x to the third. So the ln is the outside function, so I'm doing that first. Equals 1 over x to the third times the derivative of the inside, which is 3x squared. You can leave it just like that. If someone did simplify it, they would get 3 over x. It will often simplify down pieces like that. And let's do 21. This will be then one of each. Y equals 4 to the 4x fifth. So if you're not sure what to do, look at the function. What type of function is it? It's an exponential. It's always going to reappear. So we're going to start with 4x to the fifth, times, there's some number it's off by, that's the ln of 4. It's always the ln of the base. Then times the derivative of the inside, which is going to be 20x to the fourth. So there are the 3 rules we have. Derivative of e to the x, derivative of something to the any base as an exponential, and the derivative of ln of x. And you can apply those on the problems you're assigned to work on tonight, and from the ones from class today. So there's another video tomorrow with a little more info. Good luck.